interlocks in high voltage vehicles. So hybrid electric vehicles, fuel cell vehicles, doesn't make a difference, you find them everywhere. Hello friends, welcome. We are here today with a new video and we're gonna talk about interlocks. On my side again, my good friend and colleague Daniel. Good to have you back finally.
It's been a while.
Let's dig ourselves with you together into that topic. You see here a bunch of different manual service disconnects which Daniel brought with us. And we have our Unitrain system here, which is basically showing the high voltage system or the different three parts of a high voltage system of a vehicle. So we're talking about the high voltage battery, the inverter and the electric motor. And where you directly see the link between the real world and the training system is our orange plug here. So the MSD, the manual service disconnect, we have here the big guys and here our small guy. All right, mate. Interlock.
Yeah, so it's a very important component when it comes to safety within hybrid and electric vehicles. So as you mentioned, it's a component that allows basically the controller, whatever you want to call it, there's lots of different names. So there's the ECU, the control module, the BMS, whatever the component is that is overlooking the system. This allows the computer to identify that someone has essentially tried to open a component of the vehicle, a high voltage component of the vehicle, and that will immediately shut down the contactors or the relays that are transporting the high voltage to or throughout the vehicle.
So the interlock basically, when there's now coming a guy and it says, I haven't seen an interlock. So how would you explain that to a person then? How can I see the interlock? Because basically the interlock is hidden inside the vehicle. It's not like that you have a obviously point where it's coming out, except those MSD switches here. But basically, it's like a network running through the whole high voltage system, right?
Yeah, absolutely. So there's a couple of different things that we'll show here. So first of all, we've got real connectors from vehicles. So this is from different training systems that we're working on right now that are going to have some real components on there like this. So as you said, this is the DC cable that would, for example, come from the battery to the inverter.
This is why I just have two cables?
Exactly. Very good. Pick that up well. Two cables, DC.
Thank you.
If it's coming from the inverter to the motor, of course, we'll have three cables as well. Got a little one here for the AC. It's just got some test cables in there now. That's why they're
that would be the question. No, so normally it would be orange as well.
Absolutely.
Everything high voltage will be orange or is orange.
Absolutely. So anything above 60 volts DC, 30 volts AC will be orange. Or as you mentioned, manual service disconnect. So these manual service disconnect is the modern name for this. Started out being called a service disconnect. And this is a typical example from the older ones that you see from Toyota. And
or Audi.
Or Audi, this one exactly from Audi. Some modern ones that you see here are a little bit different, a little bit bigger. This one, for example, is from a truck that you see. This one here is actually called a mini manual service disconnect, even though it's quite big. And this one here is also for light vehicles, but it contains a large fuse.
Even if it doesn't see really light, so it's a pretty tough guy.
Exactly.
But basically you can say everything it has all the same intention. It doesn't matter how different those things are looking. It's like on the one side, they carrying the high voltage, so the high current basically, not the high voltage. And on the other side, they have the small connection for the interlock, right?
Exactly. So, and it's not always just the high voltage components as well. So obviously, the point is that if someone opens something, so in this case, it's the cables or the connectors carrying the voltage and the current. If someone tries to open that, it'll immediately shut it down. Sometimes you often see it in the low voltage section as well, but this will serve the same purpose. So this is obviously just a connection without the cables on it, but this is what we see now is a low voltage service disconnect. And this one here is also a part of the interlock, but it's not containing the high voltages itself. That's why the green as opposed to orange.
There is a good little story on that side. So this guy here was at the BMW i3, when you go back in time, the very first versions. I'm pretty sure BMW used the orange one here as well. And so that led to high confusion, as the people thought, oh, when it's orange, it is high voltage, but it is not. So this guy doesn't have to do anything with high voltage. It just is bearing the interlock, and that leads to shutting down the high voltage system.
Exactly.
And just at this point, shutting down the high voltage system doesn't mean to discharge the high voltage battery, all right? It just means that we disconnect the high voltage battery from the rest of the high voltage system.
If we have a look on our within our LabSoft course for this unit, we also have a couple of examples where the interlock is on a cover. So here it's a part of a current carrying system, so the cables or the manual service disconnect. But in this case here, we actually see that it's just a bridge connector that is a part of the cover. So this, what we're seeing right now, is from a Toyota Prius.
3.
And right on the end here, we can see this little connector, and that's our interlock. And the bridge connector was on the cover. So when you take the cover out, you actually are opening that bridge connector.
And you interrupt the interlock basically. So the goal is always that when you open something, you interrupt the interlock before you are able to touch anything which has to do with high voltage.
Absolutely. So on this other example here on the BMW i3, if you have a look right here, there's also another little plug. You need to disconnect that before you can slide the connector out, which then allows the connector to come apart. Same on Volkswagen, had a similar system.
So it's like a mechanical lock there in that case. You cannot open the switch as long as there is this physical block, let's say that way.
And they often integrate that into a lot of different connectors that you find in electric vehicles. It's not simply just being able to disconnect it. It's, it's trying to make it as obvious as possible what you're doing.
Yeah.
So, for example, with the different connectors that we see here, so it's partly open right now, but there's a multi-stage connection to this. So you have to pull this section up first. So if you try and pull it up, that's the first lock. Pull it up to here, and that's also locked again. We have to sort of push down on the connection underneath, get it up, and then we can undo it here.
But this task you always have to do with your safety gloves, right?
Absolutely. So